Hi guys, well, that will be a short video. This is just a video that I made on request of a few viewers that interestingly asked what is my more complicated design I made till now. Well, I said, why not? Of course, it's a paid design. It is a prototype, a paid prototype that I cannot reveal everything. Yeah, but this is what you see here. I made it 2015. No, sorry, 2017. I lost even the count of the year count, and it should have been. I made 7 of these ones and 4 of a different design that I'll show you in a jiffy, in a second. Same functionality, but different platforms. Should be a DVB-T Set-Top Box. Yeah. Prototype at the end never was realized, never went in production because it was too expensive. At the end, it was too expensive just to watch TV. So let me show you the first version, and it is this one. The first idea was to use a Raspberry Pi, the 4 or 3, or I don't know what we wanted to use at that time, and to make just a head for that, like that. The idea was, or the request from the customer was, single-sided placing of components, and only dual layer because of the costs. It was quite tricky because it is an RF, mostly an RF design PCB that works in the DVB-T and 900 megahertz or something frequency, DVB-T1, and this is how it looks. It has a very special chip here that takes serial DVB data, converts it to an I and Q signal. This thing generates the carrier signal for the DVB-T2, and here we have an IQ modulator. This, of course, I can show for analog devices. That takes the IQ signal, combines it, puts it on the carrier that this thing generates here, and then we have a small power amplifier here, as you can see. And that's it. That's going out. It was from a long time ago. Power supply, USB input. It was connected to the Raspberry Pi 3 USB, and this connector here was used just for power, and in case that we have used a serial, high-speed serial instead of the USB. The options. This thing was completely hand-soldered, completely. Not with an oven, not with a hot plate, hand-soldered. At that time, I did everything hand-soldered, and I made 4 of these. It was quite a pain in the ass. Took quite some time. At the end, this was quite fast rejected, not from me, but from the customer, because of the cost of this thing here. it costed 2 or 3 times the whole system here, and it wasn't feasible. Yeah? So this went away. The work I did was for nothing. Okay, I got it paid, but it was for nothing. And we went to this solution. This is a solution that I made it 7 times, 7 prototypes, same. It's a little bit more interesting because here we had the possibility to use a Wi-Fi too. The difference to the previous one is that I used an Orange Pi, much, at that time, a lot cheaper, under the half, yeah. So this is how it looks inside. This is the cooling pad. Look at how thick this thing is. The idea was to use the whole, let's go back, the whole aluminum chassis, the whole aluminum case as an heatsink. There was no fan allowed because it should have been a customer grade design. It was the first prototype. Switch mode power supply. The Orange Pi itself. Does it remind you anything? Does it remind you my GPS NTP server? Well, it's based on this design. Then next idea was to not use this card for the firmware, but to use a small USB stick, a very, very mini USB stick. Again, this was the first prototypes. Worked perfectly. A little bit different design here. Yeah, let's see it like that. This I made with an oven. I had enough with hand soldering. It has a different end stage and amplifier, power amplifier, much more powerful than the previous one. The same IQ modulator and the same chip here. Sorry, but I cannot reveal the customer, neither this chip here. This was a challenge to make because, again, I had the restriction, only one-sided populated, only one-sided PCB assembly, and only a dual layer, even if it is a high-frequency part. But it worked, but never went into production, because even that this thing was a lot cheaper. You can see it how it is connected. A lot cheaper. Still, the whole thing was too expensive what it should do. The DVB data, digital video broadcasting data, in form of DVB-IP and IP packages, multicast packages, were received from one of the LAN ports. The software on the Orange Pi did what it did and transmitted the DVB data directly through USB here to the RF. Yeah. As I said, again, a prototype. This is not the most complicated one I made, but it's the most complicated, but I still have something to show. From the others, I don't have any prototypes anymore. I have a few others that are quite more prototype, not RF, but I don't have it anymore. So this is what I can show you. yeah, was an interesting experience. It was the first time that I used PCBs as front and back planes. This is because of that design, of that prototype. Yeah, so everything went well and I learned something too. So guys, that's all. Thank you for watching. Please subscribe to my channel. Give me a thumbs up if you like what you see. As I said, just a short video to show, based on a request, on viewer request, which was my more complicated design I made till now. As I said, this is not the most complicated one, but this is the one that I still have, and I can show you something. I don't have from the others anything left. Looks not bad, huh? Cheers! See you. Thank you for watching. Stay safe. Bye.